So the mean, we can say here, is not a good representation, and that's pretty much the data that you're trying to gather from your standard deviation to go into your analysis of the data that you've gathered. Okay, so let's put this together. The data table shows the lengths of 120 different pike fish. And so we've got a length, we've got a distribution graph here, which means that we've got ranges. And then we have frequency over here to the right. We want to write down the modal class. And remember that the modal class is playing off of the word mode, and mode means it has the highest frequency. So the highest frequency here is 46. The modal class then is the range that includes that 46. That's 50 and 60. So 50 to 60. So the highest frequency of this data happens between the range of 50 and 60. The second half of this then asks us to find estimates of the mean, median, and standard deviation. So the reason why it says estimates is because if we were to put this into our calculator, there really isn't anywhere on here in our calculator to do a range of data. So what we have to do, we have to put specific numbers into this list. What we have to do is we have to put the class midpoint into that, which means we need to find the midpoint, the class midpoint. So we'll do class midpoint for each of these guys. So halfway between 20 and 30 is 25. 30 and 40 is 35. You can see the pattern there that goes on. So that is our class midpoint. And we use the class midpoint kind of like our Voronoi diagrams as the nearest neighbor interpolation, that we use this midpoint to reference the data within that range. So we're using that as the representation of that data. So we're going to go into our calculator. And we want to find the mean, median, and standard deviation by plugging in 25, 35, 45, 55, 65, and 75. And then we go through and do our frequency. And then we use those numbers to find it. So I'm going to ask you now to give me the mean, median, and standard deviation. So these are the numbers that you should have gotten. You can see that they're represented in the calculator. You can just grab them from there. Your standard deviation, your mean, and then your median is down here along with your 5-point number summary. And those are called estimates because it's not a true actual representation because we have this range of data. That is the only reason why it's called an estimate. You're not just guessing. It's saying use this data appropriately, but just understand that the data that you get back is an estimate because you estimated that range. Realized standard deviation of 11.3 is a fairly large range. That range takes you in and out of one of these distribution guys and into the next level. So it kind of makes sense that your standard deviation would be 11.3. That's out of 54.4. So 54.4 is right here is where your average is, which if you look, it's also within the same range as your modal class. And also your median is within the same range. So your mean, median, and mode are all the same range, which means that you're going to get a fairly centralized data tendency, which is that bell curve, which is something we tend to say that we like in statistics. And then your standard deviation is 11.3, which means it takes you on either side of the class. It means that your standard deviation, then the bulk of your information that's centralized around the mean is up to here and down to here. So you have a lot of your bulk within this area, which you can kind of see from these numbers anyway. It's just, that's what it is. All right, last two examples. Another common IB question is then for you to like calculate things like median or mean or standard deviation, and then you're going to be asked to change the data and then find the new mean, median, and mode and standard deviation and all those things. In this case, we have 5 students that took it's supposed to be trial test. Here are the scores. We're going to find the mean, median, and standard deviation, which you can totally do on your own. And then we're told that we're scaled out of 40. So we're taking out of 120 and turning it into out of 40. And so we're going to talk about how we deal with that. So right now, go and find your mean, median, and standard deviation, as well as IQR. Here are the numbers that we should get for our median, which you should just find again on your calculator. It's not represented on this calculator over here to the side. Your interquartile range, you take quarter 3, subtract quarter 1, and you should get this number. Your mean, again, is given to you in your calculator, and your standard deviation is also given to you. Really straightforward. It should be pretty quick. Then, if these scores are scaled to be out of 40 instead, going from out of 120 to going to be out of 40 means that then we divided these guys by 3. So if you take all of your scores and divide by 3, so your original score and your new score, these will be 20, 24, 29, 32, and 37. So I want you to go ahead and now find the new median, IQR, interquartile range, mean, and standard deviation. These are the numbers you should be getting on your calculator. If you are still getting these numbers wrong at this point, I highly recommend you writing down on your notes saying, I need to ask Ms. Connor how to do this on my calculator, or Ms. Megan, and ask me in class, because this is definitely something you should be feeling really confident with, and it should be getting really quick. I want you to notice a few things. 29 times 3 is 87. 87 was our original median. 12.5 times 3 is 37.5. So 37.5 divided by 3 gave us our new interquartile range. Our first mean was 85.2. If you divide that by 3, it is 28.4. And same with your standard deviation. 17.9 divided by 3 is 5.95. So the general idea here is that if you are changing your data by multiplication or division, all of these numbers change exactly the same way. If you're scaling it down, your range, your interquartile range, mean, median, mode, they all then are divided by 3 and will still be the same if you're taking all of your data and changing it. If you're multiplying and dividing, take all of these guys and divide and multiply exactly throughout. If you're adding and subtracting, most of it will change. The only thing that won't change is your range, because you would just be shifting your box plot to the left or to the right. You want to be like scaling it up or scaling it down. So your range and your interquartile range would stay the same. Everything else then would be add 4, subtract 4. We'll have a warm-up problem the next time we see each other dealing around that. So just be aware. But that is how you do it. Yes, this is an IB question. Yes, this will come up again. Yes, you will see it. Yes, you should know it. If you're multiplying, dividing, You should multiply, divide exactly the same way throughout all of your data. If you're adding and subtracting, everything else will be added and subtracted along the same way as well, except for your range. Because if you're adding and subtracting, you're just shifting it. You're not changing how wide the range is. All right. So I would like for you to do this on your own and answer the questions as follows. You are not given any individual points of data. You're just told what the original average reading was, which is your average or your mean. You're told what the original standard deviation was and what the original range was. And then you're given a conversion rate. One, and that's supposed to be mmol per liter, is equal to 18 milligrams per DL. I don't know what these measurements are, but that's the conversion rate. And if you want to convert it into this, you have to multiply by 18. So what does that do to all of these data points that you get from calculating the 5-point number summary? And that is it.